So the Geauxbot 3D printer as a system comes with plenty of 3D models that are already preloaded on the SD card to get you going. These objects are education, gaming, animals, tools, you name it. But what if you have a model that you want to make that's not on this card? Maybe you've already created it, or you want to learn how to create it in the 3D modeling software. Maybe someone else created it for you, or you found one online. You have to have the proper software and the settings to do that. In this video, we're going to show you how to set up the software, which is free, and the settings, which are also included for this 3D printer. This process is called slicing. That's taking your model that you created in a computer program and preparing it for 3D printing. It takes a little time to set up, but once you have it set, it's pretty much ready to go. There are many different settings you can actually go into this, but we're going to start with the basics right now. With the 3D printer system, you should have a flash drive. On the flash drive, you have the software, you have the settings, and everything you need to get started. Plug in the flash drive that came with the 3D printer. Navigate to the folder to find the Setup Repetier host and double-click to install the file. Once the program Repetier has been installed, go ahead and open it. Once Repetier is opened, look at the top right of the screen for printer settings. Click the icon with the gear by it. Navigate to the Printer Shape tab. Make sure that Home X, Home Y, and Home Z are set to 0, X min to 0, X max to 85, bed left 0, Y min 0, Y max to 80, bed front 0. The print area width should be set to 85, the depth to 80, the height to 94. Go ahead and click OK when you're done. Next, go to the Slicer tab. Drop down to the Slicer selection and select Cura Engine. Click on Configuration to bring up the settings. Select Import and go to the flash drive that came with the 3D printer and look for the Geauxbot 3D setting. Double-click to install the file. Click on Close. Once you have the default settings loaded for the Geauxbot 3D printer, leave the rest on the screen as they appear here. We'll go through the rest of those later as far as adhesion, infill, support types, and speed. We'll cover that later on in the video. To load your own objects to the 3D printer program, go to the Object Placement tab, click on the plus to add object. Navigate to the folder that you have your files located. Double click and you'll see the model loaded onto the platform in the program. The next step is to go to the Slicer tab. Select the Geauxbot 3D in the print configuration. Set adhesion to whatever you need. For right now, we'll keep default set to none. Infill to 20% and the extruder, Geauxbot 3D. Once you have those set, click Slice with Cura. The model will be sliced. And the next window is the print preview where you can see how long your model will take to complete and how much material is needed. The last step is to actually save the file to your SD card. So click Save the File. You can actually save straight to the SD card or to your computer. Navigate to a place where you want to save your files. When you save the object, it'll save it as the .g-code file. This is the file type that you need to load onto the SD card to go into the 3D printer. Once you have the software and this process set up, you're now able to make your own designs, your own models, or even find some that other people may have uploaded on the internet or given you, and now you can use with the Geauxbot 3D printer. Now that you have the program set up and ready to go with the proper settings, we're going to go through some of the basic or common settings that you may change from time to time. That's going to be the infill, the support material, the brim and raft, and even the top or bottom layers. Now each of these things do different things, but we're going to show you each one and how they affect the prints. So the first setting is infill. Infill is the density inside the 3D model itself. Now as you can see here, this is a molecule ball that was not finished. I cut it off so you can see it inside of the 3D print. Now a 3D printer can print from 0 to 100% filled. That means completely hollow to 100% filled. Most 3D printable objects are in the range of 20 to 40%. I typically go from 20 to 25, but it depends on what you're trying to do. If you really have a model that needs really tough or really dense, infill to maybe make it stronger or last longer, then you would bump that up some more. But as you can see, there's different type of patterns you can choose on the inside. I just typically stick with reticular. That means lines going across each other, and we'll show you how to change that now. The infill slider tab allows you to change the infill settings, whether you want no infill or 100% solid. One of the most popular settings that you may change is actually support material setting. The support material is made for objects that have issues printing without assistance. That means objects like this statue. This is the Heisman Trophy of Joe Burrow. Go Tigers. This thing on this arm is support material, all these little casings. This object would not be able to be printed without engaging or turning on support material in the program. We'll show you how to change that. But to explain to you a little bit more about support material, 3D printing starts from the bottom and works its way up. And as it goes up, the layers continue to build on top of each other. If you have an object like this with an arm extended out, the plastic would actually fall to the ground and never even make it, and it would just be a jumbled mess. So what happens is the 3D printer puts these little structures, tiny structures that break off, just like this. Pretty easy. Now you have to be careful with some objects, but the object of the support material and to use it is to make your object 3D printable. And some of the stuff can actually be pretty dense depending on your object, but you can just turn that off and on with the click of a button. We'll show you that now. If your model needs support material, go to the Slicer tab. Make sure you choose the correct Geauxbot 3D settings. For the support type, we're going to choose Everywhere. This means that it'll put support material everywhere it's needed. Now this is the only thing we need for this model. Once you have that set, check your other settings, make sure they're correct, hit Slice. In the next window, you actually see the model, what it will look like with support material. So depending on your model, it may be complicated or maybe even less dense than this. What if you have an object that is 100% solid that you've either 3D modeled or you found online? For instance, you found this online or you created an object and you didn't make any voids in the inside. And you go to 3D print this thing and it's going to be 100% solid. What's the purpose of it? Well, that depends on what you're trying to accomplish. This model we found online. We didn't create it. But this model was 100% solid when we brought it in the program. There was an issue. We didn't want to do it solid. We wanted to do ornament, 3D ornament for Christmas. So what we did is we actually went in the program and said 0% infill. That means no infill at all. We also said no bottom. So what happens is it was 3D printing, it didn't create any infill and it didn't create a bottom. So now we can put a light in here and actually light it up for Christmas ornaments. And you can do the same for a vase. The difference is for a vase you would say no top, no infill, and then you would have a vase that you could put things in. We'll show you how to change those settings right now. First, load your object. And in this case, you can see this object is actually larger than what the 3D printer can print. So we're actually going to go here in object placement and select scale. Make sure this is locked to scale proportionally. We're going to enter 0.5, which means it's going to be half the size so we can fit it on our print bed. The next thing is go to the Slicer tab. We're going to select infill density to 0, no infill. Click on configuration. We're looking for solid bottom infill under structures. Uncheck that box. Make sure you click save to save your settings. Then hit close. Now select Slice with Cura and we'll see how the model will come out. And if we rotate around, you can actually see that it will be empty on the inside with no bottom, and also showing the print time left. Another setting you may use from time to time is the brim setting. When you turn on the brim setting, what happens is the 3D printer 3D prints an edge around the base of your perimeter of the prints. This is used to help the edges from the bottom from curling up. It also helps from warping, and it's really good for sticking to the bed a little bit more. Now this 3D print that we designed was okay, but we noticed time to time one of the edges may curl and would really deform our prints. So engaging that brim layer helped to have this extra layer on around the outside, which actually you peel off at the end. And if it gets messed up during printing, it's okay. If you need to turn on the brim for your model, make sure you first have the default settings selected, Geauxbot 3D and print configuration, and Geauxbot 3D and extruder 1. Our infill set to 20 because that's what we need. We keep the speed, whatever it is. We don't need support material. Our quality is 0.1. And under adhesion, we're going to select brim. You can change these settings in configuration. If you look under brim width, you can actually change this. We'll keep it here for now. If you change it, make sure you hit save and close these settings. Now let's click Slice with Cure, and we're going to look at the preview. Now this is 10 millimeters of material that's wrapped around the base of our object. Once you have the software and this process set up, you're now able to make your own designs, your own models, or even find some that other people may have uploaded on the internet or given you, and now you can use with the Geauxbot 3D printer.